session. In today's session, we are going to discuss about what are all the availability of Indian energy scenarios, the energy resources available in India, like coal, fuels, oils, nuclear power plants, etc. So, in this session today, we are going to see about Indian energy scenarios. First, the coal supply of India. Regarding coal, the coal dominates the energy mix in India, nearly contribution of 60% of the total foreign energy production. And in this coal, India is the third largest producer of coal and lignite in the world. So the coal deposit, though we are having enormous amount of coal, the coal deposits are mainly confirmed where in India it is, the eastern parts of India and the southern central part of the country. So using this coal, the electricity generation, we are having the biggest consumer of coal, and mainly the electricity generations in India are produced by the coal. So nearly 60% of our electricity generation depends upon the coal, followed by steel industry, cement and paper industries, etc. So where the coal is available in India is majorly Jharkhand, Odisha, Chhattisgarh, West Bengal, Madhya Pradesh, Andhra Pradesh and Maharashtra. So in this state, nearly 99.08% of the total coal reservoirs occupies in our Indian countries. These states occupies the 99%. In this particularly, the Jharkhand has a maximum share of 26.4% for the overall reservoir of coal, and followed by the state of Odisha 24.72%. So the past year, according to past year statistics, reservoir of coal and lignite, we are having nearly 306.6 billion tons are available, and the lignites are 43.25 billion tons are respectively. So the availability of coal in India, according to the RP ratio, that is a reservoir to production ratio. Another 210 years we can utilize the coal in India. If we compare to the world, means the world reservoir, coal reservoir is expected to last only for 182 years as per RP ratio. And when we come to the oil supply, India is very poor in oil reservoirs. So, but we are the third largest consumer in Asia and the fourth largest oil consumer in the world. So, and India imports nearly 70% of the crude oil, mainly from the Gulf nation, and its daily oil requirement is nearly 3509000 barrels per day. Oh, so huge amount of oil, but we are not having the oil reservoirs in India, but we are nearly importing 70% of the crude oil. And last year statistics, nearly the estimation resource of crude oil in India is 763.48 million tons. So major of the reservoirs of the oil means Krishna Godavari basin, some Assam Ganges, and the sea source of Vapi. We are having the reservoirs of the oil. Mainly sector-wise means the oil, petroleum products consumption mainly for nearly 42% of the transport, followed by domestic and then industry with 24% and 24% respectively. And when we come across the natural gas supply in India, the reservoir only 8% of the energy consumption we are using the reservoirs is available in natural gas. So based upon the last year consumption, The demand is around 200 million cubic meters per day, and the gas reservoirs are estimated at 660 billion cubic meters. So maximum use of natural gas is in fertilized industry. Maximum the natural gas are utilized in industries, that is a 32.56%. And next in power generation we are using 31%, and um, nearly 8.60% of natural gases was used for domestic fuels. When we come across the nuclear power supply, the nuclear power supply to contributes the 2.4% of electricity generated in India. Only 2.4% of the electricity generation depends upon the nuclear power, and the total installed capacity is 5780 megawatts. So India is having the 7 nuclear reactors producing the electricity, and more nuclear reactors have been approved for construction. So far, 7 nuclear power sectors are installed. In Tamil Nadu, Tamil Nadu state itself, 2 places the nuclear power plant. One is at Kudankulam, we all know, and another one is the Madras Kalpakkam. Then in Maharashtra, in Tarapur, there is one nuclear power plant of 1440 total capacity megawatts. In Kudankulam itself, we are having 1000 into two units, 1000 into 1 and 2 units. And total capacity of nuclear power sectors nearly 7 sectors all over the India, 5780. When we come across the hydropower plant means, India is very blessed with hydropower plants, hydroelectric potentials, and ranking means nearly 50 in terms of hydro potential of global scenarios. And India is endowed with economically exportable and hydro potential. Nearly 84,000 megawatts we are generating the power by only hydro. In addition to that, nearly 6,780 MVA in terms of installed capacity of many small, mini, and micro schemes have been assigned. And 56 sites of pumped storage schemes are also we have installed capacity of generation of nearly 94,000 megawatts by the hydropower. So, according to last year statistics, the total installed capacity of the hydropower in India is 4262 3.42 megawatts. So, these are all the conventional energy which we are using in India. So, according to the energy scarcity and energy consumptions for power generation and energy utilization, in future we have to shift to renewable energy supply, because these renewable supply are available enormous in the country. These resources are available in enormous in India. So we have to, in future we have to slowly switch over to renewable energy instead of using this conventional energy, non-renewable energy sources. Maybe in India, 75% still the energy generation, power generation, we are depending upon the only non-renewable energy resources. So renewable energy supply means India has a vast potential of wind, solar, biomass, and small hydro reservoirs. And total potential for renewable energy power generation in the country, according to last statistics, is very low, 147615 megawatts only. When compared to non-renewable energy, the utilization of renewable energy is very low only. So this includes what are all the renewable energy percentage we are using is maybe 69.6 percentage of the total renewable supply comes from wind. Wind power energy is the first renewable energy resources in India we are utilizing. Then second one is the SHP potential of 19749 megawatts occupies at 13.38 percentage, and the third position by biomass, by using the nearly 17.5 megawatts, nearly 11%, 11.88 percentage we are using, and the 5000 megawatts, nearly 3.39 from the packages based co-generations by the sugar mills. Utilization of renewable sources are increased to large extent as compared to the earlier years. So, according to the last year statistics, the electric power generation in megawatts from various renewable sources are given below. So, a small table column is given below by the renewable energy resources. Small hydro power 4146.82, by wind power 24376.26, biopower 4545.63, and solar 4346.82, and the total capacity is 37415.43 renewable megawatts. We are generating the power by the renewable energy. And electrical energy supply, the total installed capacity of the electrical power supply is 2,81,423.39 megawatts as per last year statistics. And the main sources of the electricity power comes from the hydro. That is the 22,623.43 megawatts, and the thermal, by using the coal only we are getting the large amount of electrical generation, that is then 1,95,604.44 megawatts annums. This thermal energy which we are obtaining from the coal has to be slowly change over to renewable energy. And by the nuclear power plant we are getting 5760 megawatts, and renewable sources, by renewable sources we are only obtaining source for 37,415.43 megawatts. So consumption of electricity, um, mainly industrial sectors are the largest share of increasing the electricity generation, that is the 43.83 percentage, and the domestic 22.46 percentage, and agriculture 18.3 percentage. The commercial sector is 8.72. And from the beginning of the freedom of India, 1947, the energy utilization per capita consumption is given only 163 watt hour in the year of 1947. So every 5 years, the fifth plant have been established, and the first plant, second plant, third plant, annual plant have been reported here, and slowly the energy consumption per capita of kilowatt hour has been increased in India, and nearly the 12th plant see 1010 watt hour per capita consumption. The energy consumption is goes on, and the energy demand and energy consumption is goes on increasing this way. So we have to utilize the energy in a proper way by monitoring the utilization of the energy consumption of the all industries, industries and domestic as well as the industry purpose. We have to monitor cleanly. We have to monitor cleanly, and the utilization has been, the energy utilization by this equipment should be monitored, and the wastage of power should be reduced. So that's why We go for the energy consumption act have been created for the utilization of energy and the conservation. The conservation, the future requirements of the energy and the conservations available for the demand. We goes for the energy auditing and the energy monitoring and energy targeting. So, energy, what is energy monitoring and energy targeting? Primarily, we can say the management techniques as the energy information as a basic to eliminate then waste, as we said before, the waste, to eliminate the waste and reduce, and how to control the current level of the energy use and improve the existing operating procedure. By this procedure, we can save the energy, the existing operating procedure. So it's based on principle. What is the principle about the energy? What we can say? You can't manage and what you don't measure. You can't manage and what you don't measure. So the monitoring is essentially aimed at establishing the existing pattern of energy consumption, and the targeting is the identification of energy consumption level which is desirable as a management goal to work towards the energy. So the utilization such as fuel, steam, refrigeration, compressed air, water, effluents, and the electricity are managed as controllable resources. So the energy utilization of each center should be closely monitored, and the utilization of the energy used or compared with the production volume or some other suitable measures of the operation. Once this information is available on a regular basis, once the energy utilizations by the each resources are have been monitored in a regular basis, then we can fix a target and set uh, towards the measurement of regular basis, and some remedies action can be taken and the implementation can be. So the monitoring and targeting program have been effectively taken towards the energy conservation and energy utilizations that they shows reduction in the annual energy cost. So if we closely implement the monitoring and the targeting towards the energy system, we can reduce the annual energy of the cost in various industrial sectors between 5% to 20%. What is energy management? Term energy management means many things to many people. And by seeing definition, one definitions for a best definition for the energy management is the judicious and effective use of energy to maximize the profit and minimize the cost and enhance the competitive position. And another definition for energy, we can say another definition for energy management is the stages of adjusting the optimizing the energy using the system and procedures so as to reduce the energy requirement per unit of output while holding the constant or reducing the total cost of producing the output system. And what is energy auditing? Energy is nothing but this inspection, survey, and analysis of energy flow for the energy conservation in the building process or system to reduce the amount of energy inputs in the system without negatively affecting the outputs. So this is the energy auditing. And how we can implement the energy auditing? First step, we have to identify the opportunities, how to reduce the energy expense and carbon footprint. As per the Energy Conservation Act 2001, energy audit. What is energy audit? According to the Act, it is nothing but verification, monitoring, and analysis of the use of energy, including the submission of technical report, conducting the recommendation, and improving the energy cost benefit analysis. And we go for a action plan to reduce the energy cost. And for implementation of the energy auditing, a micro-level approach have been given. If we give them any process or unit operation, energy input as a A, which gives them the theoretical requirement, we can consider the theoretical requirement as B, and the unavoidable losses as C, and avoidable losses of the particular energy consumed equipment as avoidable losses. So the energy input which is given to the process, we have to what are all the we have to monitor unavoidable losses, avoidable losses, and the theoretical requirement. And what is energy auditing focus? Energy auditing focus is nothing but you have to concentrate on avoidable losses and identify the ways and how to reduce the energy, and the last is the implementation. The type of energy audit is nothing but type of energy audit is, depends upon the function and what are the type of industries and how depth to which the final audit is needed, and what are all the potential and magnitude of coal reduction decides. So by this factors, the type of energy audit differs, and it is classified into two types only. One is the primary audit, and second one is the detailed audit. So now next we are going to see what is preliminary audit. Preliminary audit is nothing but it is a methodology relatively. We can easily preliminary audit is nothing but how to say quick auditing, quick auditing. Establish the energy consumption in the organization, and then establish the scope for saving, then identifying the most likely area for attention, identify the limitation improvements, and set a reference point. Using this assessment, the primary energy audit can be done and uses the existing and easy attaining data. Detailed auditing means after the preliminary audit, by using the preliminary audit, we can make a quick audit. That is a preliminary audit. Detailed audit is also a methodology which evaluate the major energy using the system. That is the detailed energy project implementation plan for a facility. So this type of audit offers the most accurate estimation of energy savings and cost, which consider the interactive effects of all projects and accounts for the energy use of all major equipments. The next includes the detailed energy cost saving calculations and the project cost. So, the detailed audit can be classified as phase 1, phase 2, and phase 3. In phase 1, pre-auditing phase, phase 2, audit phase, and phase 3, post-auditing phase. So, in detailed energy auditing, we are going to divide it as a phase 1, phase 2, phase 3 sectors. Yeah, conducting energy audit, if we have a glance view, that is industry to industry, methodology of energy audit need to be accepted. 10-step methodology for the energy audit at field level is represented below. And for the implementation of this detailed audit, an energy manager and an energy auditor have been appointed to follow and to implement these steps to start or add a change as per the needs of the. So in phase 1 pre-auditing phase, the step 1 is the plan of actions. That is the plan. First thing is the plan organize, then walk through the audit, then informal interview with the energy manager or production manager comes under the step 1 category. Step 2 category, the plan of action will be the step 2. In step 2, meeting will be conducted and organized some awareness programs in all division heads and persons concerned. And in phase 1, the pre-audited activities are the energy audit is necessary for the efficient workers. So a structural methodology should be carried out in the energy auditing, and the initial study, record the study should be carried out, and as per the planning of the procedure necessary, and audit is very most important. So the energy audit can be initially start with the site visit and preparation required for detailed auditing. Initial site visit maybe one day or we can make the site visit and gives the energy auditor an opportunity by meeting them in personal concern and to familiarize him with the site and to access the procedure necessary to carry out the energy audit. Just the initial visit, what they have to do is the energy auditor or engineer should what they should do there. They have to discuss with the site senior management. That is the ultimate aim of the energy audit. They have to discuss with the economic guidelines associated with the recommendations of the audit and analyze the major energy consumptions data with the related persons and site drawings where the site drawings are available and the building layouts, steam distributions, then compressed air distributions of electricity distributions, etc. All those things should be discussed by the energy auditor with the senior engineer of that particular site. And the main aim of this visit are to finalize the energy audit team and to identify the major energy consumption areas and the plant items that we surveyed during the audit and to identify the existing instrumentations, additional metering requirements and what is the decides whether some meters will have to install to period to the audit. For example, in terms of kilowatts hours, steam, oil or gas. And you have to identify the instrumentations required for carrying out the audit. And by all this, you have to plan with time and to frame a proper plan chart by collecting the macro data on the plant energy resources, major energy resources. And to create, finally, you have to create awareness through the meetings and and in phase two, what you have to do in the phase two, that is the step 4 plan of action is the primary data gathering and a flowchart diagram have been created and the energy utilization diagrams also created. And the step 4, the plan of action is you have to conduct the survey and monitoring by which gives the results of measurements, motor survey, and insulation levels, and lighting surveys, and the portable instruments for the collections of more and accurate data. And the step 5, the plan of action is conduct of detailed trials and the experiments for selected. And the step 6, the plan of actions are the analysis of energy usage of that particular equipment or the particular area or a particular industry which results the energy and the material balance we can give as well as the energy loss and the wastage analysis by this. And the step 7, the plan of action is the identification development of milk and opportunity. And step 8 for the energy auditing, detailed auditing as plan of actions of cost benefit analysis. And step 9, the plan of action and energy detailed energy auditing is the reporting and presentation to the top management. And the last step, step 10, is the plan of actions of the detailed energy auditing. That is in phase 3 post audit phase, the implementation and the follow up. And what is the now the overall what is the role of the energy manager? Energy manager has to prepare the annual activity plan and which should be presented to the management concern about the financially attractive investment to reduce the energy cost. And second, they have to establish the energy conservation cell. With that, with familiar with the management culture should be there in the energy conservation cells about the mandatory and the task of the cells. And the third, they have to initialize the activities to improve the monitoring and the process control to reduce the energy cost. Then the energy manager should analyze the equipment performance with respect to energy. And the energy manager, their role is ensure the proper functioning and the calibrations of instrumentations which are required to the access level of energy consumption directly or indirectly. And the energy manager role, so they have to prepare the information materials and the internal workshop should be conducted related to the energy conservation topics to the concerned staff who are working in that industry or to other faculties and some non-teaching faculties. They have to prepare some information about that particular and by workshop the energy manager should then the energy manager should improve the disaggregating of energy consumption data. Then energy manager establish a methodology how to accurately calculate the specific energy consumptions of various products, service, or activities. And energy manager should develop and maintain a training program for the energy efficiency of the operating level. And he have to coordinate and fixing the nominations of management person to the external program. And the energy manager should create a knowledge bank on sectoral, national, and international development of the energy efficiency technologies. And the energy manager should create a management system by informational transmissions. The energy management manager should develop an integrated system of energy efficiency by the environmental upgradation. He should update his knowledge in the energy efficiency area by the national level and international level by improving the network and the knowledge sharing. And the energy management manager should coordinate the implementation of energy audit by improving the efficiency improvement projects to external agencies. And finally, the energy manager role is to establish and participate in information exchange with the other energy managers of the same sector through association. So with this, we complete today's session of energy auditing and the energy monitoring and how the energy targeting and how the energy audit phase 1, phase 2, phase 3 methodologies have been done. And at last we have discussed about the role of energy manager, how the energy auditing has been done, have been carried out in this session today.